I'm Swarnalatha, working as a professor in the Department of Electronics and Communication Engineering. Today's lecture, we are going to discuss about the definitions on the probability and random variables. So first, before going to the probability, first we'll see what is experiment. So define experiment. So what is experiment? An operation which can produce some well-defined outcomes is called as an experiment. Each outcome is called as an event. So what does it mean? It is some operation. So by performing that operation, it is producing the outcomes or results. That is nothing but what? Experiment. For example, I toss a coin. So when I toss a coin, I'll get the outcomes as head and tail. So this is called as what? Tossing a coin is called as what? Experiment. So tossing a coin. So this is a operation. Tossing a coin, nothing but this is the operation performed, so that it is resulting some outcomes as getting head or tail. So that is definition of what? Experiment. An experiment is an operation that produces some outcomes is called as what? Experiment. Similarly, if I conduct a PN junction diode experiment. So for PN junction diode, I want to find out the characteristics of the PN junction diode. So for that, what I am doing, I am taking the circuit diagram and then connecting the circuit diagram. After that, I am observing the voltage and current of that the diode by varying the supply voltage. So this process is called as what? Experiment, because this I am performing some operation. What I am doing here, I am connecting the circuit and then I am giving some input supply voltage and then I am observing the output. So it is resulting some output, nothing but it's producing the output voltage, diode voltage, and observing the current across the diode. It means this operation or this process of doing some operation to result an income is called as what? Experiment. And each outcome is called as what? Event. And the next definition is what? Define random experiment. So what is a random experiment? In an experiment where all possible outcomes are known and in advance. If the exact outcome cannot be predicted, it is called as what? Random experiment. So we are having two types of experiments. They are deterministic experiment, and then we are having a random experiment. In the probability theory, we will come across the random experiment only. Now, what is a deterministic experiment? That is nothing but it is an experiment where the outcomes can be predicted in advance. Performing the operation is called as what? Deterministic experiment. For example, PN junction diode characteristics. So I am connecting the circuit diagram, I am giving the supply voltage and observing the voltage across the diode and correct. And before connecting, only I know that what outcome, what voltage and current has to be obtained across the diode. It means the outcomes are well known before conducting the experiment. That type of experiments are called as what? Deterministic experiment. And the second type of experiments are random experiments. The name itself saying that random. Nothing but when you perform the experiment, you know what are all the possible outcomes, but you don't know what exact outcome is going to get. That is nothing but what? Random experiment. And the example for this random experiment is, for example, if I toss a coin and the sample space for this is what? Nothing but 1, 2, 3, 4, 5, 6. So tossing a die. So this is what? Experiment. And when I conduct this experiment, when I toss a dice, then what are the outcomes I'm going to get? I may get a number either 1, 2, 3, 4, 5 or 6. It means I may get any number from 1 to 6. But I know what are the outcomes, what are the possible outcomes I'm going to get when I conduct this experiment. But I don't know what exact outcome I'm going to get. And nothing but what? If the exact outcome cannot be predicted, then that type of experiment is called as what? Random experiment. And the next definition is what? Trial. So what is a trial? Any particular performance of a random experiment is called as a trial. Nothing but each time you are conducting the experiment. For example, I have tossed a coin for 2 times. So first time I toss a coin, I got head. And second time I toss a coin, I got tail. Third time again I toss a coin, I got tail only. So each performance of the experiment is called as what? Trial. And next definition is what? Define Bernoulli trial. So the Bernoulli trial and the trial definition, the difference is, in the trial I may get any outcome out of the all the possible outcomes. But in the Bernoulli trial, it consists of only two possible outcomes. Then that type of experiment is nothing but what? Bernoulli experiment, and each trial is called as what? Bernoulli trial. So what is a Bernoulli trial? A Bernoulli trial is a random experiment with exactly two possible outcomes, like success and failure, or when I toss a coin, so I may get only two possible outcomes, either head or tail. When I conduct the exam, I may get only two possible outcomes, success or failure. When I launch a missile, so I may get either hit or no hit. So like that, if the outcome consists of the random experiment consists of only two possible outcomes, and each performance of that experiment is called as what? Bernoulli trial. And that type of experiments are called as what? Bernoulli experiments. And the next definition is what? Define outcome. So outcome is nothing but what? The possible results of an experiment is called as what? Outcome. So for example, when a die is rolled, what are the possible outcomes? I'm going to get 1, 2, 3, 4, 5, 6. So these are called as what? Getting either 1 on the die, 2, 3, 4, 5 or 6 on the die. Nothing but the results of the experiment is called as what? In simple way I can say that the results of an experiment is called as what? Outcome. And what is the sample space? Is very important. The sample space has been defined, represented by the symbol capital S. So what is the sample space? The list of all the possible outcomes when a random experiment has been conducted, or the set of all the possible outcomes of a random experiment is called as what? Sample space. Now when I die a roll, so when I roll a die, then what is the sample space for that? What are all the possible outcomes I'm going to get? So 1, 2, 3, 4, 5, 6. I may get only from 1 to 6 only. So when I roll a die, so I will not get either 7, 8, 9, 10. So because on the die will have only the numbers from 1 to 6. Therefore, the list of all the possible outcomes when a random experiment is conducted is called as what? Sample space. Similarly, when I toss a coin, what is the sample space for that? Head, tail. And the sample space has been represented by the symbol here, capital S. And the list of each element in the sample space will represent by what? Small s. What is capital S represents? The sample space, nothing but the list of all the possible outcomes when the experiment has been conducted, and each element in the sample space is represented by small s. And similarly, for example, if I toss a coin for 2 times, this is only one time or only one coin at roll, and here I toss for 2 coins. Then what is the sample space for that? Totally how many possibilities? If I take only one coin, the number of possible outcomes are nothing but 2. Now if I take 2 coins and then if I see the sample space for that, then what the number of possible outcomes for that? 2 square, nothing but what? 4. What is 2 here indicates? For single experiment, for a single coin, or if I connect the tossing a coin for one time, or if I take only one coin, the sample space elements, the number of sample space elements, nothing but here, yes. So that power, if I connect for one time, nothing but 2 power 1 equals to 2. If I connect for 2 times, then the sample space element consists of 4 elements. Like what are the 4 possibilities? And the first coin head, and the second coin also head, and the first coin head, second coin is tail. So first coin tail, second coin is head, and on both the coins I may get tail. So this nothing but what? The sample space when I toss 2 coins at the same time. The number of possible outcomes are what? 2 square. Similarly, if I toss 3 coins, then what is the number of elements in the sample space? 2 cube is nothing but what? 8. Like head, like that, I am going to get totally 8 possibilities. Like that, I can write down the sample space for single trial, 2 trials, and similarly for n number of trials also. And what is a discrete sample space? A discrete sample space is one that has only discrete values and countable. For example, if I take this experiment rolling a die, what is the sample space for that? 1, 2, 3, 4, 5, 6, 9. It means the elements, if you observe the elements in the sample space, they are of discrete in nature. They are not continuous. In between 1 and 2 don't have any values. Between 2 and 3, no. It means they are discrete values and they are countable. You can count the number of elements. Then nothing but what? Discrete sample space. Now, what is the example of continuous sample space? For example, if the experiment like choosing a positive real number. So, positive real number from, for example, 1 to 10. So, from 1 to 10, how many real numbers are going to get? From 1 to 10, you may have n infinite number of elements between this 1 to 10. Therefore, this type of sample space is called as what? Continuous sample space. The elements are of continuous in nature as well as they are not countable. Then that type of sample space is called as what? Continuous sample space. And the next definition is what? Define event. Out of the total results obtained from a certain experiment, the set of those results which are in favor of a defined result is called as what? Event. And it is denoted by either E or A, B, C like that. So what is the event is nothing but sample space is nothing but the list of all the possible outcomes. So out of all the possible outcomes, I am interested some list of possible outcomes. So out of all the possible outcomes, I am interested only in some outcomes. Then that is called as what? Event. For example, when I roll a die, the sample space for that is what? 1, 2, 3, 4, 5, 6. Now on the sample space, I am defining what is my experiment here? Rolling a die is my experiment. What type of experiment is it? Random experiment, because the outcome cannot be predicted. And what is the sample space for that? 1, 2, 3, 4, 5, 6. And defining an event on this sample space. What is that event? Nothing but choosing or getting only odd numbers. Getting only odd numbers. When I roll a die, I am interested only in the outcomes getting the odd numbers on the die. Then what is that event? E is equals to 1, 3, 5. It means what? Now what is the definition of event? Event nothing but what? It is set of only the interested results or defined results is called as what? Event. And next definition is what? Define equally likely events. So equally likely, the name itself saying that when there is no reason to expect the happening of one event in preference to the other, then the events are known as what? Equally likely events. For example, when I toss a coin, the sample space for that is what? Head and tail. I am defining two events on that, getting a head, and defining one more event, getting a tail. So I am defining two events on this sample space. One is what? Getting a head. Other event I am defining is what? Getting a tail. Now, getting a head, this event and the events even E2 are said to be what? Equally likely, because getting a head is equal probability with getting a tail. Then those events are called as what? Equally likely events. And next type of definition is what? Define exhaustive events. So what are exhaustive events? Nothing but all the possible outcomes of the experiments are called as what? Exhaustive events only. So head and tail. When I toss a coin, the sample space for that what? Head and tail. So what are the possible outcomes? Nothing but getting head or tail. So this is also called as what? Exhaustive events. For example, I am defining an event E3 as getting either head or tail. So getting either head or tail, nothing but what? It is a sample space only. So the list of the possible outcomes in the experiment is called as what? Exhaustive events. And what is a mutually exclusive events? The name itself said mutually exclusive. Nothing but no two events having common elements. No two events having common elements is called as what? Mutually exclusive events. Therefore, the definition here, if there be no element common between two or more events, then that type of events are called as what? Mutually exclusive events. For example, when I roll a die, the sample space for that is 1, 2, 3, 4, 5, 6, which is a list of all the possible outcomes. On this, I am defining two events. One is nothing but getting only the odd numbers. Nothing but out of the, what are the outcomes here? 1, 3 and 5. And defining one more event. I am interested in only getting the even numbers on the die. Nothing but 2, 4, 6. Now, these events and even and the event E2, these two events are said to be what? Mutually exclusive. Why? Because these two events are not having any common elements. Then these two types of events are called as what? Mutually exclusive events. Now there is nothing but E1 intersection E2 equals to what? 5. And what? Mutually exclusive events. And next type of event is nothing but simple event. What is a simple event? A simple event is one that can happen only in one way, or if it is having only a single outcome, that is called as what? Simple event. And next type of event is nothing but compound event. So what is a compound event? A compound event is an event that has more than one possible outcomes. Then that type of event is called as what? Compound event. So when I am defining a tossing a coin in that, I am defining one event getting a head only. So nothing but is having only one outcome. So it is having only one whether. Suppose this type of event is called as what? Simple event. For example, I am defining the same experiment, I find one more event getting either head or tail. Then this event consists of more than one possible outcome. Therefore, it is called as what? Compound event. And next definition is what? Dependent events. So when can you say that two events are dependent? So you can say that two events are said to be dependent if the occurrence of one event changes the probability of the occurrence of the other event. Then those two events are said to be what? Dependent events. And for example, when I roll a die, I am choosing two events. One is what? Getting odd numbers, nothing but 1, 3, 5. I am defining one more event, that is nothing but what? Getting a prime number. Now this events E1 is said to be what? E1 and E2 is said to be dependent events, because if I select the occurrence of selecting nothing but if I select number 3 in the die, then in the event E2 I can't select. Therefore these two events are said to be what? Dependent event. The occurrence of one event is depending upon the occurrence of the other event, then that type of events are said to be what? Dependent events. And the next definition is what? Independent events. So it is exactly opposite to dependent events. If the occurrence of one event is not depending upon the occurrence of the other event, then those events are said to be what? Independent events. Next, to define intersection of two events. The name itself saying that what is intersection? Nothing but if two events occur at the same time, both occur at the same time, then that events are said to be what? Intersection of two events. And what is union of two events? Nothing but the union. Nothing but what? Either one event A or another event B occurs. Then it are both occurs. Then it is called as what? Union of two events. So the intersection of two events are represented by A intersection B, and the union of two events are represented by what? A union B. And what is the complement of the event? Nothing but A bar. So what is the complement of the event? The complement of an event A consists of all outcomes of the experiment that do not result in the event A. Then that event is called as what? Complement of the event. This is like a set operations only. The set operations, in the sets you have intersection and union and then complement operation. In similar manner here also, events also, because event is also type of set only. That's why it is also what? What are the operations they are performing to the sets, the same operations can perform to the events also. So next definition is what? Define probability of occurrence of an event. So what is the probability of occurrence of an event? Nothing but it is a measure of likeliness that an event will happen, or the probability of occurrence of an event is defined nothing but the ratio of the number of trials in which the event occur to the total number of trials. For example, if I conduct the experiment tossing a coin for 5 times. Out of 5 times, I want to calculate the probability of getting 3 heads. Then what is the probability of that? Even nothing but what? 3 by 5. So how many times the experiment has been connected for total number of times? Nothing but 5. And I'm interested only getting a head. So the probability of this getting the number or getting a interested outcome to the total number of outcomes. Nothing but what? Probability of occurrence of an event. Next definition is what define axioms of probability. So having 3 axioms of probability. The first axiom of probability is the probability of any event is always a non-negative real number. So it may be either 0 or it is a positive real number. It is a not only number, it is a. So in between it means the probability of any event should be always greater than or equal to 0. Never will not get the probability of any event less than 0, nothing but negative number. Always get a positive number only. And moreover, second axiom of the probability is when S is a sample space in experiment, then the set of all the possible outcomes P of S equals to 1. What is the second axiom here? P of S is equals to 1. What is the sample space here? The set of all the possible outcomes. And what is the probability of the sample space? Because it is 1. Why it is 1? Because when I conduct the experiment, definitely any one of the outcome will occur out of all the possible outcomes. That's why the probability of the sample space is equals to 1. Therefore, we can say that the probability of any event, what is the minimum probability here? I got 0. And what is the maximum probability here? I got 1. Therefore, the probability of any event lies between, not between, it includes 0 and 1 and is between 0 to 1. So the minimum probability is 0, the maximum probability is 1. Whenever you calculate the probability of any event, it should not get less than 0 or should not get more than 1. Always the minimum is 0 and maximum is 1. In between only how to get. That is the second axiom of the probability. And third axiom of the probability is if A and B are mutually exclusive events, then P of A and B equals to P of A plus P of B. Because what is A and B is nothing but A plus B minus A intersection B. Therefore, what is P of A and B equals to P of A plus the probability of the event B minus the probability of intersection of those two events. Now, what type of events are given? The events are given as A and B are mutually exclusive. For mutually exclusive events, what is the intersection B equals? They don't have any common elements. That is called as what? Mutually exclusive events. And what is the probability of mutually exclusive events? If you don't have any event, then it is null set. Nothing but 0 elements. So 0 by total outcome, nothing will get 0. Therefore, what is the probability of union of two mutually exclusive events? Nothing but the sum of the probabilities of the individual events. So for mutually exclusive events, the probability of union of those events is equal to what? The sum of the probability of individual events. The same thing can apply for n number of events also. Here I have taken only 2 events, like that you can take n number of events and you can define it. And next definition is what define relative frequency probability. So frequency is nothing but what? How often the event A occur is the measuring of that event, nothing but what? The probability of that event, nothing but relative frequency probability. So for example, when I toss a coin for 100 times, so out of 100 times I am defining one event getting only 10. So I have out of 100 I got 60 times as 10. Then what is the probability of that event? Nothing but what? 60 by 100. Nothing but based on the number of occurrences, I will define the probability. Therefore, this is called as what? Relative frequency probability definition. And second one, the definition is what? Define classical probability. What is classical probability definition? The probability of an event is a ratio of the number of cases favorable to it to the total number of all the cases possible. For example, when I roll a die, what is the sample space for that? 1, 2, 3, 4, 5, 6. I am defining an event such that getting a numbers only 1, 3 and 5 only. Then what is the probability of that event? What is classical probability here definition? It is nothing but what? Ratio of what? The number of cases favorable. So for this event, how many number of cases favorable? Here 3. And what is the total number of favorable outcomes here? 6. So 3 by 6, nothing but what? 1 by 2. So this definition is called as what? Classical probability. and based on the number of times the event occurs, then the probability definition is called as what? Relative frequency probability. And the next definition is what? Define joint probability. So what is joint probability? Joint probability is a statistical measure that calculates the likelihood of the happening of two events occurring together at the same time is called as what? Joint probability. For example, if we have two events x and y, then the probability of x intersection y is called as what? Joint probability. The probability of occurrence of two events at the same time is called as what? Joint probability. For mutually exclusive events, the joint probability is equals to 0. And the next definition is what? Define conditional probability. So what is the conditional probability? The probability of an event x is given, then another event y occur is called as what? Conditional probability of x given y. It means what? P of x by y. The conditional probability of an event to the event y, nothing but how it is represented by P of x by y. How it is reduced? It is represented as what? The probability of an event x and given. So this event is depending upon some condition. What is that condition? Nothing but y. Then it is called as what? Conditional probability. What is conditional probability definition? P of x intersection y by P of y. So this is called as what? Conditional probability. For example, so on the rolling a die, what is the sample space for that? 1, 2, 3, 4, 5, 6. So I am defining two events. One is getting the odd numbers. I am defining one more event such that getting the prime number. What are the prime numbers out of 1 to 6, 2, 3, 5 and the odd numbers from 1 to 6 are 1, 3, 5. Now I want to calculate the conditional probability of the event E1 such that the event E2 has been occurred. What does it mean? So they have given that the outcome has to be a prime number only. The outcome has to be only a prime number. And I want to calculate the probability of getting the odd number. What is here is called as what? The probability of getting the odd number and given. They have given some condition. What is the condition they have given? The outcome should be a prime number. Then how can I calculate here? P of E1 intersection E2 by P of E2. So what is E1 intersection E2? How many elements are common here? 2 elements are common. So here 2 by 6 by, and what is P of E2? Total how many possible here? 3 out of 6. So 3 by 6. Nothing but what? 2 by 3. So this is called as what? Conditional probability. And the next definition is what? Total probability. What is total probability? The total probability of an experiment means the likelihood of its occurrence and towards by varying the smaller events that can be composed of. What does it mean? So, for example, an event A. So, an event A is calculated in terms of what? N mutually exclusive events. So, an event A has been defined out of N mutually exclusive events. An event is composed of N mutually exclusive events. And the probability of this event is called as what? Total probability. So first, how do you define the event for total probability? Define event A on events such that they are composed of what? N mutually exclusive events. Then what is the total probability of event A? For that, P of A is equals to what? Sigma N equals to 1 to N. So I am defining this event on N mutually exclusive events. Let us say B1, B2 and so on Bn. These are what? N mutually exclusive events. Okay. Now on this, what I am defining here? I am defining an event here on this N mutually exclusive events. Then what is total probability of the event is equals to sigma N equals to 1 to N. P of A by Bn. P of A by Bn into P of Bn. So this is called as what? Total probability of an event A, which is defined on a set of N mutually exclusive events. And what is the next definition here? Bayes theorem. So this is very important. And the total probability and conditional probability. These are very important definitions. So what is the Bayes theorem here? So the Bayes theorem nothing but what? The probability that an event A occurs given that another event B has been already occurred, which is equal to the what? Probability of that event B occurs given that A has already occurred, multiply the probability of occurrence of event A and divide by the probability of occurrence of event B. So again, extend the concept of total probability to the Bayes theorem. So what is the event A? I am defining on what? N mutually exclusive events. So I am defining an event A and this what? N mutually exclusive events. Now I want to calculate the probability of any one of this event to the event A which is defined on this set of n mutually exclusive events. Then how it is defined as what? P of A by Bn. So here let us say Bn where n equals to 1 to A. So P of A by Bn into P of Bn by P of A. So here what is P of A equal total probability? Nothing but sigma n equals to 1 to n P of A by Bn into P of Bn. Then this is called as what? Bayes theorem. What is the Bayes theorem here? So I am defining an event A on the set of n mutually exclusive events. Next I want to calculate the probability of any one of these mutually exclusive events, and given that the total event A depend on this set of these n mutually exclusive events, that equals to what is the ratio of what? The conditional probability of that event occurs to Bn to the probability of that mutually exclusive event by the total probability is called as what? Bayes theorem. And next definition is what? Random variable. So what is a random variable? A random variable or random quantity. It is a variable or stochastic variable. The other name for random nothing but what? Stochastic. Which is described informally as a variable whose values depends on the outcomes of a random phenomenon. So in simple words, if I want to define a random variable, so for example, a random experiment has been conducted. What is a random experiment? The experiment where the outcomes of that experiment is known, but you cannot predict the exact outcome. That is called as what? Random experiment. Now, what is a random variable? So, on this, when we conduct the random experiment, you will get the sample space. The sample space may get consist of either numbers or it may consist of descriptive in nature. The sample space, for example, when I roll a die, what is the sample space for that? 1, 2, 3, 4, 5, 6. Now, when I toss a coin, what is the sample space for that? Head, comma, tail. Then, similarly, if for example, if a student has been written the exam, I want to know the probability of either the student has been passed or failed. Then, the sample space for that means what? Pass and fail. It means some sample space consists of some descriptive numbers and sample space. Some sample space for a random experiment may consist of in descriptive nature. These two are in descriptive nature. This is in numbers. Then, in order to convert this sample space into real numbers, nothing but what? Random variable. What is a random variable? A random variable is a function of the sample space elements. Nothing but the random variable is depending upon what? The outcomes of the experiment. So how they are defined? Nothing but what? For example, I am defining random variable x. Then the random variable x has been defined as what? It is a set of real numbers. It is a set of what? Real numbers where the real numbers are this random variable is a function of what? The outcomes of that experiment, nothing but the sample space elements. Or it is also defined as what? As a random variable is a set of all the functions of all the elements in the sample space where for each element you are assigning a real number. For each element what? You assign some real number according to some definition, according to some rule is called as what? Random variable. For example, so when I toss a coin, when I toss two coins, what is sample space for that? Head, tail, head and tail. Now, for defining the random variable on this sample space, yes. How I am defining here? I am defining as what? Number of heads. I am defining the random variable on this sample space what? According to some rule, nothing but number of heads. Then x equals to what? Number of heads. So here in the first outcome, how many number of heads are there here? 2. Therefore per head, head. For second and third outcome, and how many number of heads are here? Only 1 head. Nothing but head comma tail and tail comma head. And for the fourth outcome, the number of heads are what? 0. So it means what? For a random variable, it consists of only real numbers. That is the first rule. And this real numbers depends upon what? The outcomes of the experiment. That is called as what? Random variable. Therefore, what is x equals here? 0, 1, 2. But the sample space is discrete in nature, but always random variable consists of only a real numbers. So these real numbers are assigned according to some rule in the sample space. Then is called as what? Random variable. Next, again the random variable are classified into three types. They are continuous random variable, discrete random variable, and mixed random variable. Like how the sample space has been divided into three types, like continuous sample space, discrete sample space, and mixed sample space. In a similar manner, the random variable is also classified into three types. They are continuous random variable, discrete random variable, and mixed random variable. So what is a continuous random variable? A continuous random variable is one that has continuous range of values. For example, x equals to 0 less than equals to x less than equals to some 100. So from 0 to 100, how many elements are going to get real numbers? We may have infinite number of elements. Therefore, this type of random variable is called as what? Continuous random variable. And what is discrete random variable? A random variable is one that has only discrete values. For example, x equals to 0, 1, 2, 3, 4. So these elements are discrete in nature. They are not continuous and they are countable. It is called as what? Discrete random variable. And what is mixed random variable? The random variable consists of both continuous range of values and discrete values. It is called as what? Mixed random. It is a combination of these two. Nothing but mixed random. For example, so 0 less than equals to x less than equals to 10, and then have 11, 12, and 13. So it consists of discrete elements as well as the continuous elements. Therefore, this type of random variable is called as what? Mixed random variable. And the next definition is what? Define probability mass function. A probability mass function is a function that gives a probability that a discrete random variable is exactly equal to the some value. It is called as what? Probability mass function. The probability mass function is applied to what? For discrete random variable. So for discrete random variable, for example, here I have given p of x equals to 0. So here p of x equals to 0, p of x equals to 1. So this is called as what? And so on. It is called as what? Probability mass function. The probability that a discrete random variable exactly takes a value is called as what? Probability mass function. Now what is the next definition? Define cumulative distribution function. CDF. Nothing but cumulative probability distribution function. So how is it defined? The cumulative probability distribution function of real value random variable x is the probability that x will take a value less than or equal to x is called as what? Cumulative probability distribution function. For example, x is a random variable, then the cumulative probability distribution function of that random variable has been represented by what? Capital F. So the capital F is used to represent the distribution function. So the cumulative probability distribution function of random variable x is nothing but the probability of the random variable x takes up to the value of small x is nothing but what? Is equals to what? Cumulative probability distribution function. Next, what is a probability density function? A probability density function which is written by what? PDF, nothing but small f. Always the small f represents what? The probability density function. So it is a function whose value at any sample in the sample space can be written as what? Providing a likelihood or nothing but probability of the random variable equal to that sample. Nothing but what? Fx of x. And the relation between the distribution function and the distribution function, nothing but what? The differentiation of the distribution function, what? The density function. And for discrete random variable, so what is fx of xi? Nothing but what? P of x equals to xi only. It is called as what? The probability density function. Only for that sample only is taking the probability. It is called as what? Probability density function. So in today's lecture, we have seen some definitions on probability and then random variable. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.